Welcome everyone to our YouTube channel Agri Addict. Today's discussion is for the weekly mock test of soil science, and today's topic is the soil testing and basic chemistry. Okay, so this is for the ICAR PG exam. So let's come to our first question. What is the main objective of soil testing? Okay, let's see what are the objectives are written here. To evaluate the soil fertility status and for making the fertilizer recommendations for a specific crop, field and farming. Okay, to predict crop response to fertilizer applications. Okay, so to classify soils into different fertility groups such as low, medium and high categories of those for soil fertility map. To identify the type and extent of the soil related problems like salinity, alkalinity, acid and acidity. So these are the four options, and for the main objectives of those the soil testing, and all the four options will be correct. So let's understand one by one. To evaluate the soil fertility status, so by soil testing we have, evaluate those soil fertility status, that is if it is the amount of fertilizer nutrients in the soil and the concentration in the soil solution and also in the adsorbed phases. So by this we can make the fertilizer recommendations. So for field, for a specific crop or any field, there the fertilizer recommendations differ from one from each other. So what happens is, when we know what is the fertility status, by soil testing, after knowing the soil fertility status, we can recommend the farmer, or for the or any experimentation purpose also we can recommend that if what amount of fertilizer actually is needed. Okay, so to predict the crop response, not only the fertilizer recommendations, but also how much the fertilizer will affect the crop in their growth, it will also be corrected or also be predicted by the soil testing. And to classify the soils into different fertility groups, we can classify those the soil in different fertility groups as low, medium and high categories of the soil fertility map. Okay, and also to identify the type and extent of the soil related problems, we can also find the different soil related problems, basically those problems like salinity, alkalinity, acidity, which majorly affect the crop production. We can identify those type of soil related problems. So the objectives all four will be correct. So here the option B, C will be correct. Okay, let's come to the next point. Next question. Given below are two statements. Let's see one by one. The statement one is normal phase HPLC. HPLC is high pressure liquid chromatography. Okay, uses a polar stationary phase and a non-polar mobile phase. Okay, next the statement 2 is reverse phase HPLC uses non-polar stationary phase and polar mobile phase. First, come and understand what is actually this high pressure liquid chromatography. This is a high pressure liquid chromatography machine. Okay, so here what happens is, a mobile phase is run through this, it is the solvent delivery pump. Okay, after that it is thrown, or it is pressed to the column. So in the column there is a stationary part. That means mobile phase means it will flow through this machine. Okay, so after, and the stationary phase will help in separating those chemicals, that is the liquid sample. So in liquid sample, this is a mixture of some different chemicals or different components. So what happens, mobile phase will carry this liquid sample with it, and then it will come to the column. Then if there is a stationary phase there, that means it is not moving actually. It will help only in separating all together, all the components together will separate the mixture component in different bands. Okay, and after that these are passed through a detector. This convert the amount of each component into electrical signals. By the electrical signals we can identify which component was there in that liquid sample, and also the amount of that component and the percentage or the ratio of that. And what is normal phase and what is reverse phase? It mainly based on the stationary and the mobile phase. Okay, so in normal phase, this both the options are correct. In normal phase what happens is, the polar stationary phase are polar, and and the mobile phase is non-polar. Means this is polar stationary and this is non-polar. So what happens in that sample? There is some components are there is polar and some components there are non-polar. Okay. So what happens after when we pass with the mobile phase, then the polar components get attached to the polar stationary phase, and the non-polar components will elute first. Elute means it will go out of this system first, because it polar will attract polar most and the non-polar will get less attracted. That means the the nearer band will be polar, the farther band will be for the non-polar components. So this is the normal phase. Here it is right that HPLC polar stationary phase. So by this we can know different thing, that in that case in normal phase what component will elute first. That means what will be not restricted of flowing of that flow. So as the polar stationary phase is there, so stationary phase will try to attract or will try to restrict the flow of the polar components. So non-polar actually non-polar will elute first in the normal phase, and in the reverse phase just opposite. Here stationary phase is non-polar and mobile phase is polar. So in that case mobile phase, that is polar, will elute first. And in normal case there is something more questions can come from that, that usually what kind of phase is used. Usually reverse phase HPLC is used. Okay, these are the three major things that can that type of question can come in the exam also. So both the statements are correct. Okay, let's come to the next question. The micronutrient cations are extracted with DTP extractant, which consists of. So DTP extractant is the micronutrient cation extractant component. So here the option will C will be correct, that is 0.005 molar DTPA, 0.1 molar TEA and 0.01 molar calcium chloride. And in this in this extraction method, what are the function of those? Let's try to understand that. DTPA, what it does, it actually chelates the cationic micronutrients and forming the soluble complex. These soluble complex are like how plant chelate by the organic acids that plant root exudes, or that organic acids can chelate the micronutrient and that plant uptake. So this system also mimic the same thing as plant. Okay. So the DTPA chelates cationic micronutrients and it becomes soluble form, and that is actually similar to the plant part. In plant soil also this kind of phenomena also happen. Okay. As a result, to replenish the soil solution, when the soil solution the chelates, all the micronutrients will be chelated, then there will be the activity of those micronutrients will be less. So by that more cations are released from the solid phase, and this process mimics the reduction or activity of the metal ion solution due to plant uptake. In plant uptake also this kind of phenomena happens. So DTPA, this function is for DTPA. What does TEA do? TEA do 0.1 molar TEA. It is TEA means triethanolamine. Mainly it uses as the buffering agent. It has the pK value of 7.8. Okay. And what is the pH of the DTPA extract? 7.3. It is a very important point. DTPA, it can come directly as a question, that what is the pH of the DTPA, that is 7.3. And the buffering capacity, it has the buffering capacity TA, triethanolamine, and it has the pKa value of 7.8. What it does, at pH 7.3, around 3/4 of the TEA is present as HTEA plus. Okay. This HTA, what it go, this ion HTA plus goes to the exchange site and replace calcium and magnesium ions. So this will go to the exchange site and replace calcium and magnesium ion. So it will be in the soil solution, calcium plus 2, magnesium plus 2, those. ions will be in the soil solution. Okay, thus increasing the solution concentration of the calcium and magnesium up to 2 to 3 times. So for this, it aids to suppression of the dissolution of calcium carbonate and calcium calcareous soils. If there is a less concentration of the calcium in the soil solution, so what happens is calcium carbonate dissolution happens to conserve or to maintain the soil solution concentration of the calcium. So here, from here actually, when there is a less concentration of the calcium, so calcium releases from the calcium carbonate. But in that case, it suppresses the dissolution of calcium carbonate because it itself helps in supplying the calcium in the soil solution. So otherwise non-available carbonate bound micronutrients may get extracted. If calcium carbonate or calcium carbonate get dissolved in the soil solution, then what will happen? The carbonate bound micronutrient can be extracted, and the carbonate bound micronutrient actually not uh, taken by the plants. So as it is not taken by the plant, so there will be overestimation, means we will get a huge amount of data for those micronutrients concentration, but actually the plant cannot actually uptake that carbonate bound micronutrient. So plant cannot uptake, so it will not actually correlate with the plant uptake. So this is the function of TEA. What is the function of calcium chloride? Calcium chloride actually it is for the mimicking the soil solution concentration of calcium. So calcium in the soil solution, we assume that it has 0.01 molar calcium, 0.01 molar calcium present in the soil solution. So for that, it can mimic the soil solution. So background solution will be like soil. And why 7.3? Exactly in that pH, actually stable complexes form. This is the reason. And 2-hour shaking is done. It is the maximum release is obtained in the first 2 hours. So these are the reasons for these extraction components, that is PEA, DTPA and calcium chloride. Next, on the next question. The role of ammonium fluoride in Bray extraction for phosphorus extraction. Okay. What are the options? Increase the solubility of calcium phosphate, decrease the solubility of aluminum iron phosphate, and increase the solubility of aluminum iron phosphate, and decrease the solubility of calcium phosphate. We know that Bray extract where we use in the acid soils, usually where the pH is less than 6.5. Okay, so here the Bray extraction is used. So in acid soils, the phosphate is bound to the iron and aluminium. So the ammonium fluoride will increase the solubility of aluminium and iron phosphates. So let's see the reaction. So this is ammonium fluoride, this is aluminium phosphate, and this is iron phosphate. What happens? This ammonium fluoride will made a complex with aluminium, like ammonium, aluminium and fluoride. Okay, this NH4 whole 3 aluminium and F6, then it comes same as in iron also. By this H3PO4, the phosphoric acid releases the soil. So this is the mechanism in the Bray extraction or in the acid soils. So one question can come, that is what is the pH range where the Bray extraction is followed? That is less than 0.5. Next, come to the next question. Flame photometry is based on the principle of, so here what are the options? It is absorption spectroscopy, emission spectroscopy, ESR spectroscopy and infrared spectroscopy. So first we have to learn about the what is the principle of flame photometer. So this is the principle. The flame photometer is known also as flame atomic emission spectrophotometer. Okay, and it operates on the principle is, here a liquid sample is which contains the cations like sodium, potassium, calcium, lithium. These are aspirated into a flame. What happens by that? This heat of the flame evaporates the solvent and dissolve the metal salts are converted into the free metal ions, free metal atoms. So by this thermal energy from the flame excites the electrons in the atoms of higher energy. We know that when we provide some energy, what happens? The electrons that is present in the lower level, it will get excited and go to the higher level or outer surface, outer orbitals. So by this, when it comes back to the ground state, when it get extracted, it goes to the higher state. When it comes back to the ground state, then it emits light or photons. This is a characteristic wavelength we found for each element. Okay, and a monochromator or optical filter also selects the wavelength of interest. Next, the emitted light is then detected by a photodetector, and the intensity of those emitted light is measured, and this intensity is proportional to the concentration of the specific element. So this is the principle of the flame photometer, that is, the sample is aspired in the flame. By the heat, it will, the electrons go to the excited phase. When it comes back to the ground phase, it releases or it emit light of different wavelength for different elements. So by this we can understand or we can know which element is present there, and by the intensity we can found the concentration. So it is actually emission spectrum. Okay, next question. Okay, this is a very important question. Which method is used for which kind of elements? Like it, you have to remember all those things. Okay, in Geldal method, it is actually nitrogen. Okay, so Geldal method, nitrogen. One trick we discussed in the previous videos also, that we try to find first with the options here, that A is 4. So A is 4 means the option will be either B or C. Then Walkley-Black method, it is mainly for soil organic carbon. Okay, it is the oxidation method of Walkley-Black method. It is for soil organic carbon. So B is 3. B is 3. So this is, A is 4 and B is 3. So by this trick we can calculate or we can get the answer very quickly, and this C option will be correct. Then the basic criteria for the selection of soil test methods. So what are the criteria? Let's see, that is the rapidity. That means the soil test will be the soil testing will be in a short time, so we can advise or we can say recommend any fertilizer doses or to the farmers and or any experimental fields. So rapidity is correct. Accurate results with reproducibility, this is also a criteria, that we should get some accurate results, and also it should be reproducible. That means we can further perform this act or this soil testing, the protocols, and by this we will get the same result or similar result or accurate result. So it should be reproducible. Predictability of crop response to applied nutrient based test result, this is also a good criteria or basic criteria, that we should be able to predict the response to the applied fertilizer. That means if we put some fertilizer, or if we apply some fertilizer, there should be a response in the plant uptake or a plant yield also. So this should be judged, this can be judged by the soil test method. Also predicting results without no, this is not correct. We cannot predict the results without performing the soil test method. So this option will not be correct. So A, B, C will be answered. What is the advantage of ICP-MS over AAS? Okay. Let's see what is the principle of ICP-MS. So the principle of ICP-MS, what is that? Inductively coupled plasma, and MS is mass spectrometry. This is actually based on the combination of high temperature ion source with mass spectrometric detection. It will perform highly sensitive elemental analysis. In that technique, liquid sample is first introduced to an argon plasma. So try to remember those points and understand that whatever I am underlining, those can be those questions can come individually also in a direct form. So so the liquid sample is first introduced to an argon plasma in the form of a fine aerosol, and the plasma created by applying a strong radio frequency, the temperature reaches to around 6000 to 10,000 degrees Celsius also. These extreme temperature, what will it do? This will remove the solvent from the sample and break down the chemical bonds, and by that free atoms will be generated. So what happened here? Actually, ICP-MS, it is the combination of high temperature ion source and mass spectrophotometry. It is done for the highly sensitive elements. Here an argon plasma is used, and the high temperature convert the sample into free atoms. This high energy of the plasma also ionizes the atoms and typically producing the positively charged ions. This then extracted plasma to a small cones. These cones are also known as sampler or skimmer, okay, which helps the transfer the ions into the high vacuum region. By this is once inside this mass spectrometer, the ions are separated according to the mass by charge ratio. So in the after removing those cations, then it is transferred to the mass spectrometer. So here mass to charge ratio, by this it is separated, those cations are separated, and most commonly used mass analyzer like quadrupole. It's an example. And after separation, what happens? The ions reach a detector which records the number and type of ions present. Okay, these are the major points and the principle of the ICP-MS. So here by this we can understand that it is a multi-element analysis. Okay, this is right. Also, it has lower detection limit. That means if it is if it is present in very less amount, it also can detect that. It also has wider linear dynamic range. It is simpler instrumentation. No, this option will not be correct. If the total instrumentation is not simpler than AAS, here the most it is very complicated also, and it is also expensive also. So this option will not be correct. So A, B, C will be the. So next question. The ratio of nitric acid and hydrochloric acid diacid mixture is 3:1, and the ratio of the nitric acid, perchloric acid and sulfuric acid in diacid mixture is 9:2. 9:3:1. So statement 2 is correct, but statement 1 is not correct. What is diacid? Here nitric acid is okay, but not hydrochloric acid. It is perchloric. So nitric acid is to perchloric acid is actually 3:1. It is diacid. You have to remember what is diacid, and it is its ratio, and also the triacids, that is nitric acid, perchloric acid, sulfuric acid in the ratio of 9:3:1. Next, ABDTPA is suitable for multi-nutrient extraction in alkaline soil. Morgan-Wolf reagent is more suited for the acidic soil. Okay, here also both the statements are correct. So let's know about what is multi-nutrient, multi-elemental analysis. So for the simultaneous multi-element deterioration, who proposed or who found or who discovered this technique? Sultanpur and Swab in 1977. They developed this solution, that is ABDTP. The component of ABDTPA, it is 1 molar ammonium bicarbonate, 1 molar ammonium NH4H3, 1 molar ammonium bicarbonate and 0.005 molar, and pH is very important, that is 7.6. Okay, this is ABDTPA, ammonium bicarbonate DTP, and this is for mainly the simultaneous extractions of those cations, and it is suitable for alkaline soil. And what is Morgan-Wolf reagent? It is a mixture of 10% sodium acetate and 3% glacial acetic acid. So this is the reagent, that is the mixture of those. This is the Morgan-Wolf reagent, and it is buffered at 4.8 pH, and it is suitable for acidic soil. And additional information for that, ammonium bicarbonate DTPA, the ABDTPA, it is also known as third cell extract. So next is, which of the following gas are used for carrier gas in gas chromatography? So in gas chromatography, where the function of carrier gas is to carry the sample component through the oven or through the column. So the carrier gas should be inert in reaction. That means it will not react with the sample. If it reacts with the sample, the component will be changed, and there will be faulty or error in the estimation of those component or analysis also. So it should be inert. So carrier gas should be inert in nature. That means it should not react with the sample. So here the examples will be hydrogen, helium and nitrogen, not ammonia. So okay, these are the three examples: hydrogen, helium and nitrogen. These are inert gases which will not react with the component, that is A, C and D. This will be the answer. And let's know about the gas chromatography also. Here also it is like the liquid chromatography, but here what happens, the carrier gas is put through this oven, then a sample injector is there, it inject the sample. Here temperature rises, okay, here temperature rises, so the sample and the sample will get volatilized, and and due to the column, some samples elute first and some sample elutes later. So by this we can get the peaks in the detector. Okay, in the detector we will get the sample which get first, which elute first or which exits exit first. It will give this peak, then after some time we get this peak, then after some time we'll get this peak. So by this peak or by this analysis we will get which kind of components were there, and also the concentration we also can get in that. It is a separation type of technique. Okay, what is the purpose of dark OG16 or activated charcoal in the phosphorus? What happens is, in Olsen method, pH, what is the pH of Olsen extraction method? It is 8.5 pH. In 8.5 pH, it actually, high pH dissolves the organic matter. So whenever we try to extract from the soil, so after filtration we get a red color, reddish type of filtrate. So this reddish type of color is actually through for the organic matter. So it is a photometrics. It is actually detected in a spectrophotometer, where the blue color intensity is measured. So if there is a color already present in the solution, so what will happen? It will interfere with the actual data or actual result. So we have to remove this color, organic matter color. We have to remove. For this, we do that, we add some amount of, or pinch amount of dark OG60, that is the activated charcoal. It has a own procedure to produce it. We'll learn it later. So dark OG60 will, what will happen? It will absorb the organic matter that is present in the soil solution, and that solution, that is the filtrate, then after filtration it will get a clear extract. So the clear extract will have, what will happen, there will be no interference of the color. So it removes the interference of the organic matter. This option will be correct. So this is actually the work or the function of dark OG60 or the activated charcoal. Charcoal will absorb the organic matter. What are the here are the two statements again. UV via a spectrophotometer, the source of the visible radiation is tungsten halogen lamp, and here the source of the ultraviolet is deuterium discharge lamp. So let's know about what are the different things regarding this. So for the visible light, the source of radiation is, try to pause and try to remember this or try to note down in the notebook also. The source of radiation for the visible light In that VIA spectrophotometer is tungsten lamp. And for ultraviolet, it is hydrogen lamp, deuterium lamp, and also xenon arc lamp. Okay. And for the infrared, it is actually Nance Glover and nichrome wire. What are the wavelength of those lights? In visible, it is 400 to 750 nanometer. In ultraviolet, it is below 400. That is 200 to 400 nanometer. Ultraviolet, actually, it is V to R. That means violet to red visible range. So ultraviolet means before or below the violet, that is 200 to 400 nanometer, and infrared is that is bigger than red. It will be 800 nanometer to 200 centimeter. Okay. And what the monochromator that is used for visible, it is glass prism, and for ultraviolet it is quartz prism, and for infrared it is sodium chloride prism. And the sample cell we use in both the cases, visible and ultraviolet ray, we use quartz or fused silicon. And for infrared we use KBr, that is potassium bromide, and NaCl. So here comes what are the options were there. The source of visible radiation, tungsten halogen lamp, it is okay, it is right. And also the source of ultraviolet is deuterium discharged lamp, so it is also right. So next question. So the match the following. What are the color in the flame photometer we get? Flame color. We have already studied in the previous question that in every atom the electrons get in the higher state, then it comes back to the lower state. So when it comes back to the lower state, it will emit some color or emit some light. So for sodium, it is yellow. Okay, for sodium, it is yellow, and for calcium, it is orange. And for potassium, it is actually violet, and the leftover, that is barium, it is for lime green. So we have to learn, we have to remember this, especially the important ones, that is mainly the sodium, calcium, potassium. These questions can come directly also, that what is the color, flame color of that, or what is the wavelength we get in the flame photometer. For sodium it is yellow, for calcium orange, for potassium it is violet, and barium it is also lime green. Next, arrange the following reagent grades in decreasing order of purity. Okay, so what is AR, GR and LR? First we know that. What is AR? AR is analytical grade. What is that? Analytical reagent grade. These are of high purity and are suitable for the analytical laboratory work. In case of where high accuracy and precision is required, when we require very precise data, and for the research or laboratory work, these analytical grades are used. GR, the full form of the GR is guaranteed reagent grade. It is also very high in purity, and also in some company it uses GR term except of instead of AR, that is analytical grade. But usually analytical grades are more superior than the GR. So it is also in high purity range. And what is LR? LR is the laboratory reagent grade. This stands for and it has lower purity than the AR and GR grades. And these are mainly used for the routine qualitative analysis and teaching experiments, and also for the industrial application where extremely high purity is not essential. So what will be the sequence? It will highly pure will be analytical grade, then it will be GR, that is guaranteed reagent, then LR, that is laboratory reagent. Okay. Then this question is alpha D glucose is optical rotation plus 112, and beta D glucose it optical rotation plus 19, but for D glucose it is 52.5. What this phenomena called? This phenomena is called as mutarotation. Now let's know what is mutarotation. So mutarotation is a change in optical rotation of a sugar, preferably which have anomeric sugar, means it has anomers. Anomers mean alpha, beta, these are anomers. So until achievement of constant value, it can change. When it achieve the constant value, like the previous example, we get that here 52.5 degree, 52.5 degree optical rotation we find, then it is constant. Until that there is a change always. So this is the change in optical rotation of a sugar, preferably anomeric sugar, and the optical rotation of D-glucose in water is 52 degree. However, the alpha D-glucose, this is the example, okay? Alpha D-glucose is 112 and beta D-glucose is 19. Another example, D-fructose. Here also, in general, the average is minus 92 degree, but however, the alpha, the optical rotations of the alpha D-fructose in water is minus 31 and beta D-fructose is minus 133. The average we get minus 92, so it is known as mutarotation. So next, a layer of ice formed on the surface of the lakes in cold regions. So this is due to the ice is less dense than the liquid water. Okay, when what happens when the ice, the water freezes and it becomes ice, some crystals formed. Okay, some crystal type of structure formed, and those are interconnected. So what happens when this crystal type of structure formed? So there is some gaps in those atoms. When the waters are connected to each other, it actually linear type of connections are seen the molecular level, and when it freezes to ice, they form a crystal shape. So the volume increases but the overall density decreases. So as the density decreases, it uplift the ice from the water. So it is the ice layer formed on the surface of the lake in the cold region. Next, there is a calculation type of question. 20 ml of solution of 3 normal HCl and 15 ml of 4 normal NaOH. What will be the pH? So what is normality? Normality of an element is equivalent weight by its in 1000 ml or its volume, you can say. Okay. So here normality is there, volume is there. So what will be the equivalent weight? Equivalent weight of HCl will be EHCl. Equivalent weight of the HCl will be N into V. That means normality is 3 and it is 15 ml. No, 20 ml. So equivalent weight will be 60. And for NaOH, so here normality is 4 and volume is, so the total equivalent weight will be 6. As the equivalent weight is equal and it is one is acid and one is alkali, so it will be completely neutralized, and when it is neutralized, the what is the pH of that solution is 7. Next, a solution contains 0.1 molar sodium chloride and 0.2 molar calcium chloride. What will be the ionic strength of the solution? So first we have to know what is the formula of ionic strength. Ionic strength is half summation of Ci Zi. This is the formula. What is C? C is the strength or concentration, like 0.1 molar, 0.2 molar. What is Zi? Zi is the valency of each individual cations. So for calculation, what we have to do? Take half, then summation. Summation of what? Ci Zi square. Ci means first sodium chloride. Sodium chloride, it has sodium, it has chloride. For sodium, what is the concentration? 0.1 molar. 0.1 molar, and what is the valency of sodium? 1. Sodium plus 1. Chloride also plus minus 1 and it has 0.1 molar. So plus this is square, okay, mi zi square. Then again a ci concentration is 0.1 molar is 1 into plus calcium chloride. What is the strength? 0.2. 0.2 into what is the valency of calcium? Plus 2 is 2 plus calcium. Now chlorine. Chlorine, what is the concentration? 0.2 into chlorine is 1. What will we will get? 0.1 plus 1 plus 4, 0.8 plus 0.2. No. Some mistake I have done. This is calcium 2, na, Cl2. So Cl2 will be, it will be 0.4 actually. 0.4. This is calcium, so 2Cl actually. 2Cl. K plus 2 plus 2Cl minus. 2Cl are there, so it will be 2 into 0.2, that is 0.4. Then 4 into 1 square. So what will be the summation? 10, 0.14, 0.14. The final answer is 0.7. This will be the answer, 0.7 molar. Okay, this is the ionic strength of that solution. Then comes, match the following: anomar, diastereomer, enantiomer and epimer. What are the definitions of that? First comes to anomar. Anomer is those stereoisomers that differ at the anomeric carbon, the cyclic. Okay, where the anomeric, in that anomeric carbon, when it differs, so it is anomer. What is diastereomer? Diastereomers are that stereomers that is not mirror image but differ at multiple chiral carbons. So this is diastereomer, okay, not mirror image and differ at multiple chiral carbons. What is enantiomer? This is the stereotypes are non-superimposable but mirror images. Yes. Okay. So that are non-superimposable but mirror images. This is enantiomer. And what is epimer? Epimer is the stereoisomer that differ at only one chiral carbon but not mirror images are found. So these are the anomer is 4, A4, no, A3, A3, diastereomer, this is 4, then enantiomer is 1, epimer is 2. So this is correct. Next, okay, so this is the structure of enzymes. This is the components of any enzyme complex, that is apoenzyme, coenzyme, holoenzyme and cofactor. First we learn what are those. So here in a apoenzyme, what happens, the protein portion, that is inactive portion in an enzyme, is known as apoenzyme. Okay, the inactive portion in an enzyme is known as apoenzyme. It, when apoenzyme and coenzyme binds with that, this is coenzyme, that is not protein part. The non-protein part of an enzyme is coenzyme. When it binds to apoenzyme, it becomes holoenzyme or whole enzyme. And if the coenzyme part is non-protein part, and it can be act as activator also, some metal cations are also present, this is also known as cofactor. Okay, so let's see the options. Apoenzyme. Apoenzyme is, what is apoenzyme? The protein part. The protein part of an enzyme is inactive without a cofactor, that is apoenzyme. Then what is coenzyme? Coenzyme is a non-protein part. Organic molecule helps in an enzyme function. This is coenzyme. Okay. What is holoenzyme? The complete. When it is complete, then it is holoenzyme. Complete active enzyme is holoenzyme, and cofactor is non-protein part. metal ion, organic molecules. So option C will be correct. Next, the deficiency symptom of vitamin A. Let's see what are the deficiency symptoms and what is the name of those vitamins, scientific name also. Vitamin A, it is retinol, chemical name. Okay, the deficiency is xerophthalmia. Vitamin B1, it is thiamine. Okay, vitamin B1. Deficiency, beriberi, workness. Then vitamin B2, riboflavin. Vitamin B2 is riboflavin. B3, niacin or niacinamide. Niacin or niacinamide, and the deficiency is pellagra. B5, it is pantothenic acid. B6, pyridoxine. Deficiency symptom, ammonia. Whatever I am circling, try to remember. Okay. Vitamin B7, biotin, dermatitis, skin diseases. And vitamin B9, it is folic acid. Vitamin B12, cyanocobalamin. Okay. Vitamin C, it is ascorbic acid. Deficiency, the disease is scurvy. Then vitamin D is argos calciferol, E tocopherol, then vitamin K is phylloquinone. Okay. Rickets, vitamin D. The deficiency disease of vitamin D is rickets. So vitamin A, that is xerophthalmia. Xerophthalmia, it is night blind. Next, which of the following pairs of vitamin chemical names and the common names? Vitamin B1, riboflavin. Let's see. B1, it is thiamine, not riboflavin. Okay. So option 1 is correct. Vitamin B2, thiamine. Let's see. Vitamin B2, riboflavin. So it is also incorrect. Vitamin B6, pyridoxine. Let's see. B6, pyridoxine. So this is correct. What was the last option? It was vitamin B12, niacin. No, it is cyanocobalamin. Okay. So option C will be next. An isotope of cesium has a half-life of 30 years. And if 1 gram of cesium 137 disintegrates over 90 years, how much will remain? So what is the formula for that? We can do it by calculating in hands also. This is 30 years. First we learn the basic, the normal without formula. First 30 years it is half. So what is the first? If 1 gram is there, okay, 1 gram after 30 years it will be 0.5 gram. Then after 30 years, that is 60 years, it will be half of this, 0.2. And after 30 years, that is total 90 years after, it will be 0.125. But when the digits are complicated, or the digits are higher in number, so we cannot calculate by this easy method. We have to know the formula. The formula is N. N is equal to, N is the final concentration. N0 into half to the power by okay. So what is N? N is the final concentration, final amount. So what will be after the question? It was na. After how much will it remain? This is N. N0 is the initial amount. Initial amount was 1 gram. So half to the power. Total time 90 years. And what was that? What was the T half of that element? 30 years. Okay, 30 years, and T is 90 years. So it will be 1 by 1 into 1 by 2 to the power 3. That means 1 by 8. Okay, so 1 by 8 is 0.125 gram. So this is the formula. N is equal to N0 into half to the power T by T half. Next, if a radioactive atom, this undergoes alpha decay, that means it will decay or it will remove one alpha particle. What will be the resulting atom? So what is alpha particle? An alpha particle is that identical to a helium. Okay, helium nucleus. So it contains, actually helium nucleus contains 2 protons, 2 neutrons. That means the Z, what is Z? Z is the atomic number. So proton number, Z will be -2, and after removing the Z will be -2, means 2 protons is removed. And what is A? It is the atomic mass. It will be 2 proton 2 neutron. Atomic mass is proton plus neutron. So 2 proton 2 neutron. If we remove 2 proton 2 neutron, that means -4. Okay, A minus 4, Z minus. The resulting component or resulting molecule will be the molecular mass. The atomic mass will be A minus 4, and for the atomic number it will be Z minus 2. So this will be next. Next, the correct sequence of central dogma. What is central dogma? This procedure is central dogma, where we know that in DNA, this is the genetic material. So from this replication happens. Replication means producing more DNAs from the same the previous DNA. It produces, replicates in further. So DNA to DNA is replication. It also goes the procedure for transcription. Transcription means this DNA will produce this RNA. Okay, this is transcription. And after producing RNA will participate in the translation. In translation, what will we get? The protein synthesis, amino acid synthesis or protein synthesis. So this procedure is known as central dogma. So what are the options? Let's see. The correct sequence of central dogma, first will be DNA application, then it will be mRNA transcription, then it will be protein. Okay, this is known as central. Next. So next, as we move down a group in the periodic table, which of the following decreases? So we have to know the trends in the periodic table. So here we can see, as we go from up to down, the ionic radius decreases. Okay, the ionic radius decreases when we move go from up to down, and when we grow just opposite, that is left to right, the ionic radius will increase. So this will decrease and this will increase. For ionization energy or ionization potential and electron affinity and also electron negativity, both will increase in this direction. And when it increases this direction, it will decrease in this. Okay. Then the non-metallic character will increase in this direction, but the metallic character, we go from right to left or up to down, the metallic character will increase. Okay. So the options, whatever are the options? Move down the group periodic, which of the following decreases? Okay. Atomic size. Let's see. So here the atomic size increases. Actually, it is increasing, not decreasing. When we go from up to down, it is increasing. Okay, atomic size, and decreases from right to left. So decreases from left to right. So the atomic radius from up to down, it increases. Okay. So the atomic radius will not be the answer. Atomic size, because it is decreasing. It is saying. So it when we go from up to down, it actually increases. Then electronegativity. Yes, this will be the right answer, because we know that electronegativity actually increases from left to right. So up to down it will be decreased. So this is the answer. The other two options will also not be correct. So electronegativity will decrease when we go from up to down in a periodic table. Next, what are the isotope, isobar, isotone, isoelectronic? So first we learn what are those. What are isotope? Isotope is same atomic number and different mass number. What does it mean? Same atomic number and different mass number. Means the proton number will be same, but there will be difference in the neutron number. So that proton plus neutron changes. And what is isotones? Here proton is same, but neutron is different. In isotones, different number of protons, but the same number of neutrons. Just opposite. Isotope proton same, neutron different. For isotones, proton different and neutron same. And for isobars, same mass number, means proton plus neutron are same but different atomic number. That means protons are different, but proton plus neutron is same. So in that option, isotope means proton will be same, but the mass number, that is neutron plus proton, will be different. So here this is proton 6 proton same, but it is mass number is 12, mass number 14. So this is isotope. Isotone what I have said, proton different, but the proton different, but the neutron will be same. So here we see that proton 14, here also proton 14, but here neutron is 30 minus 14 means 16 neutrons are there. Here also 31 minus 15, 16 neutrons are there. So neutron number is same. So it can be called as isotone. Isoelectronic means electronic means electron numbers are same. So in isobar is this, okay? This is isobar, and isoelectronic, what is in oxygen? What is the electron number, or what is the number of electrons present in oxygen? This is hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, 8. And it is oxygen minus 2 means 2 electron more, that is 10. 10 electrons present in O2 minus. Okay. And for neon, what is the electron number of neon? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon, 10. It is 10. So electron number is same. So these are isoelectrons. Next, which order reaction in the ratio radioactive decay? This is a very much important question, and many times this question comes directly. So the answer is first order reaction. Just try to remember this. It can come directly in the any type of questions, the ICAR system. So the mass of the sample in picogram method, picogram is 10 to the power minus 12 gram is 1 picogram. So in mass sample of picogram method is less than 10 to the power. So these are the most expected 30 questions. I hope you like this video, and we'll meet in the next one.